Have you ever seen a bridge walk? It sounds impossible. After all, bridges are built to stay in one place for decades. But in the foothills of China's Tian Shan Mountains, engineers do something that looks almost unbelievable. Instead of blowing up an aging highway bridge or spending weeks tearing it apart piece by piece, they lift an entire 1,800-ton structure, roll it off the highway, and dismantle it somewhere else. The operation relies on specialized machinery worth nearly 20 million yuan. That's an incredible investment just to remove an old bridge. So why go to all that trouble? And how do you safely move something that weighs as much as more than 1,000 family cars? The answer is a fascinating story of precision engineering, careful planning, and technology that almost makes a bridge seem alive. To understand how it's done, we need to start long before the bridge moves even a single inch. For thousands of years, the Tian Shan Mountains have watched empires rise, trade routes flourish, and history unfold beneath their towering peaks. Ancient travelers crossed these lands along the legendary Silk Road, while generations of explorers and merchants passed through the mountain valleys. Today, those same mountains are witnessing something entirely different. Not a caravan, not an army, but a team of engineers preparing for one of the most carefully coordinated bridge removal operations imaginable. The first challenge isn't moving the bridge, it's building the place where the bridge will eventually go. Before any cutting begins, crews construct massive temporary support piers beside the highway. These temporary foundations must be strong enough to safely receive sections weighing hundreds of tons. Every measurement is checked repeatedly, because once the bridge begins moving, there's almost no room for error. Next comes the heavy equipment. Tower cranes unload enormous hydraulic lifting systems capable of raising thousands of tons with astonishing precision. Steel support beams are assembled. Then arrive the true stars of the operation, the modular transporters. At first glance, they don't look particularly impressive, but these machines are engineering masterpieces. Instead of using ordinary steering like a truck, every wheel can rotate independently. The transporters can move sideways, pivot in place, travel diagonally, and perform incredibly tight turns while carrying enormous loads. Think of it like watching a giant shopping cart that can move in any direction, but instead of groceries, it's carrying an entire highway bridge. Before they ever touch the bridge, operators spend hours rehearsing every movement. It might seem excessive, but when you're moving 1,800 tons, there's no such thing as too much practice. Once the equipment is ready, attention turns to the bridge itself. Here's where things become even more interesting. The bridge isn't removed as one giant piece. Instead, engineers divide it into 3 carefully planned sections, but they don't simply cut straight through the structure. Each cut follows a specially designed figure-8 pattern. Why? Because those unusual cuts allow the sections to separate cleanly once the transporters begin lifting. That reduces unwanted stress on the bridge and helps prevent damage during removal. Even the placement of the transporters is calculated down to the smallest detail. Engineers determine the exact position and spacing of every support point. Move one transporter too far in either direction, and the bridge could bend under its own weight. Sometimes the biggest engineering victories come from calculations nobody ever sees. Then there's another detail most people would never notice. Between the steel support beams and the underside of the bridge, workers carefully insert specially designed blocking material. It looks simple, but it's anything but ordinary. These blocks are made from high-strength synthetic materials engineered to resist cracking and deformation under enormous pressure. They also increase friction between the bridge and the support beams, helping keep thousands of tons securely in place throughout the move. It's a perfect reminder that even the largest engineering projects often depend on surprisingly small details. Eventually, preparation gives way to action. Traffic police begin redirecting vehicles onto temporary bypass lanes, clearing the highway for the operation ahead. Now comes the moment everyone has been waiting for. The hydraulic transporters slowly come to life. Very slowly, they lift the bridge approximately 20 centimeters, or about 8 inches. 8 inches doesn't sound like much, but those few inches completely transfer the weight of an 1,800-ton bridge from its original supports onto the transport system. Everything stops. Engineers inspect hydraulic pressure. Observers check every connection. Every reading must be exactly where it should be. Only after every system receives the green light does the bridge begin its journey. Then something remarkable happens. Instead of driving straight ahead, the transporters execute a graceful fan-shaped turn. Thanks to their independently controlled wheels, they can rotate the massive bridge section with incredible precision, guiding it smoothly away from the highway. From above, it almost looks as if the bridge has come alive and decided to take a walk. Throughout the move, observers stand at each of the bridge's four corners, constantly watching for even the slightest irregularity, any unexpected movement, any unusual vibration, any change in hydraulic pressure. Everything is monitored in real time. Thousands of engineering calculations are now being tested in the real world. One section reaches the temporary site, then the second, then the third. And here's the impressive part. By the time the final bridge section has cleared the highway, traffic on the neighboring lanes has already returned to normal. That's the real goal. Efficiency isn't just about working fast. It's about minimizing disruption while completing an incredibly complex operation safely the very first time. Once each bridge section arrives at the dismantling site, another team takes over. The modular transporters carefully position each section directly above the temporary support piers. Now the hydraulic lifting systems begin lowering the load. Power lines are connected. Control systems are verified. Operators monitor everything from a nearby control room, where they can oversee every hydraulic movement from a safe distance. Slowly, almost silently, the massive bridge settles onto its temporary supports with millimeter-level precision. No explosions, no dramatic collapse, just one carefully controlled movement after another. At this point, many people wonder what becomes of the old bridge. The answer is surprisingly simple. Once all three sections have been safely removed, they're dismantled piece by piece until the bridge has completely fulfilled its purpose. Its job is finished. But that isn't really the end of the story. Every bridge removed makes room for one that's stronger, safer, and better suited for the future. What looks like demolition is actually renewal. Standing beneath the ancient Tian Shan Mountains, engineers aren't just removing old infrastructure, they're creating space for the next generation of transportation. Using hydraulic systems, advanced transporters, and years of engineering experience, they've turned one of the most difficult construction challenges into something that almost feels effortless. And perhaps that's the greatest achievement of all. When engineering is done right, the impossible doesn't look dramatic. It simply looks easy. By the time this bridge has taken its final journey, the team is already heading to their next challenge, the Shiziyang Channel project in Guangdong, where they'll dismantle another massive bridge, this time from a height of 16 meters. Because for these engineers, every bridge that quietly rolls away is proof that even the heaviest structures on Earth can move with extraordinary precision. And the next time you drive across a bridge, remember this. One day, instead of being demolished where it stands, it might simply get up and walk away.